When you gaze at the night sky, it's a sight we're all familiar with, but there's so much more behind what we see. Every night, that glowing sphere we call the moon shines brightly, and it holds mysteries and stories beyond our everyday understanding. Imagine a trip to the moon. It's 238,855 miles away, yet soon we'll travel there as easily as flying internationally. The moon's gravity is only 1/6 of Earth's. You'd feel like a superhero leaping around. While its silent, barren landscapes seem lifeless, they've witnessed Earth's 4.5 billion year history. Staring at Earth from there, a blue gem in space, is a view less than 0.01% of humans have ever seen. In the early 1960s, President John F. Kennedy made a bold declaration. Back in September of 1962, he expressed his grand vision, and it was so big that even he couldn't have possibly grasped its full implications. This was a time of exploration and discovery. Just a few months prior, in November 1961, NASA had managed to send a chimpanzee into space. Fast forward to February 1962, and it was a human. Astronaut John Glenn orbiting the Earth, not once, but 3 times. Such progress in such a short time was nothing short of remarkable. But JFK's challenge was even greater. He wasn't just talking about Earth's orbit. He was looking at the moon. Just think for a moment. Going to space is already a massive endeavor, but reaching the moon? It's an entirely different ballgame. In fact, comparing the two is like comparing a game of catch in your backyard to the Super Bowl. NASA responded to Kennedy's call with immense determination. With 7 years of intensive research, trial, error, and astronomical budget, they made the seemingly impossible possible. Yet, the moon's challenges were so vast that after a few missions, the US decided to halt the Apollo program, waiting until technology could catch up with the audacious dream of lunar exploration. Fast forward to the second decade of the 21st century, we find ourselves gearing up again for another lunar adventure. It's surprising to think that even 50 years after the Apollo missions, we're still working to replicate their groundbreaking achievements. This speaks volumes about the creativity of the early astronauts and the challenges faced by modern society. Now there's talk of a new mission called Artemis II. This mission, set for the near future, will mark humanity's significant return to the moon. This time around, it's not just men, but a diverse group leading the way. Pioneers like the first woman astronaut, Christina Hammock Cook, the first African-American astronaut, Victor Glover, and the first Canadian astronaut, Jeremy Hance, will be part of this historic journey. Overseeing them all will be Mission Commander Reed Wiseman. Just like the main objective of Apollo 8, the goal remains the same: journey to the moon and safely come back. Speaking of Apollo 8, it's a mission that deserves more recognition. It took place during the holiday season of 1968. The world watched from December 21st to December 27th as 3 brave souls made history. They were the first humans to truly venture into space, the first to view our planet from afar, and the first to witness our entire history, our wars, loves, and every little event condensed into one tiny blue dot. If you read the words of the Apollo 8 crew, you'll find they were more enchanted by the view of the Earth than the moon's rugged surface. For them, spending Christmas Eve in space, broadcasting to all of humanity, and sharing verses from the book of Genesis was a transformative experience. In a turbulent year marked by tragedies like the assassinations of Martin Luther King Jr. and Robert Kennedy and the intensifying Vietnam War, Apollo 8 brought hope. It wasn't just a scientific achievement, but a testament to human spirit and perseverance. The journey to the moon isn't just about rockets and technology. It's about pushing the very boundaries of what it means to be human. Nowadays, we usually send humans to space in a particular way. We use a SpaceX Crew Dragon capsule, which sits on top of a Falcon 9 rocket. When this rocket takes off, it's pretty powerful. Imagine it like this. The Falcon 9 has the power of about 1.7 million horses, all pushing at once. Once it's high enough, the second part of the rocket gives the capsule an extra push, taking it to within 260 miles of the International Space Station. But for more ambitious missions like Artemis, we need even more power. The SLS rocket for Artemis is extremely strong, even more so than the famous Saturn V rocket from the Apollo days. This is needed because the Orion spacecraft it carries is heavy, weighing 22 tons. Think of it like trying to throw a giant metal ball. You'd need a lot of strength. When the SLS rocket lifts off, it weighs as much as 5.75 million pounds, and it quickly goes up to 500 feet in just 7 seconds. It keeps speeding up for the next 2 minutes because of the strong boosters. After that, its main engines help it move up and out of our atmosphere. Around 8 minutes after takeoff, the people inside get to see space clearly for the first time. This is because the protective covers and the pointy bit at the top are removed. As the rocket's engines stop and the core breaks away from the top part, there's a big shake felt inside. As they float in space, they prepare the spacecraft for the next steps, including adjusting their path within the 2 burns or pushes from the engines. By now, they're much farther from Earth than the ISS, about 7 times farther. By now, they're much farther from the Earth than the ISS, about 7 times farther. Once they're in this new orbit, they hang out for a day to ensure that everything in the spacecraft is working perfectly. Imagine it as if they're checking their car before a long road trip, looking at everything from the engine to the air conditioning. The crew needs to be absolutely sure everything is fine because their next destination is the moon. If something goes wrong there, they can't just call for help, and turning back isn't so easy. So, after all the checks, the Orion uses its engine to head towards the moon. By the second day, they've spent much time ensuring everything is in order. Their next step is crucial. They have to leave Earth's gravity and move on a path that takes them to the moon, but also allows them to come back. It's a big, exciting journey into the unknown, really. The spacecraft uses a special technique to make the journey back to our planet. It goes into a broad, circular path around the moon. This method helps it gain momentum. Just like a slingshot, this isn't the close, tight orbit we've seen in a previous mission. Instead, it's a more expansive route that goes far out around the moon before heading back towards Earth. At the farthest point of its orbit, when the spacecraft is most distant from the moon, it finds itself deep in the vastness of space. This point is around 6,500 miles away from the moon's rocky surface. Interestingly, this route reminds us of the journey Apollo 13 undertook. Though it wasn't intended, Apollo 13 faced major issues, forcing its astronauts to come up with a plan on the spot to safely get back home. They ended up using a method similar to this to swing around the moon. It turned out to be a very efficient way. The spacecraft named Orion is packed with advanced features. Compared to the tech from the 1960s, Orion's computer is blazingly fast, approximately 20,000 times faster. And it's not just about speed, there's also more space inside the Orion. It's about 30% roomier than the Apollo capsule, offering around 315 cubic feet of space. For personal convenience, there's a private restroom designed similarly to those on modern airplanes. And for staying fit, a rowing machine has been installed, creating a small space for workouts. NASA is still making up its mind on the exact duration of the Artemis II flight. It could be as short as 10 days or stretch to 3 weeks, but they have a limit. The Orion crew can only be in space for a maximum of 21 days. However, NASA's goal is to utilize as much of that time as they can. They want to test out Orion thoroughly. All the data collected during Artemis II will be crucial for future missions, especially Artemis III. But until they analyze the wealth of data from Artemis II, predicting the specifics of Artemis III is hard. After going around the moon, Orion will ignite its engines for a crucial phase. It will then take around 4 days to complete the journey back home, but it's not going to be easy. Think of the Crew Dragon spacecraft that returns from the International Space Station at speeds of around 17,000 miles per hour. That's fast. But Orion, because it's coming from a much higher altitude, will hit Earth's atmosphere even faster. close to 25,000 miles per hour. This return requires precision. If Orion comes in too steep, it could burn up, but too shallow and it could bounce back to space. However, these rocket scientists are top-notch. They've factored in a margin of about 2 degrees for safe re-entry. An interesting fact? Even after suffering severe damages, Apollo 13 made a perfect landing. The capsule will endure extreme temperatures on its return, getting as hot as 5,000 degrees Fahrenheit on the outside. But don't worry, inside it remains cozy between 70 degrees Fahrenheit and 80 degrees Fahrenheit. Once the fiery re-entry is over, landing on the Pacific Ocean with the help of 11 parachutes becomes relatively straightforward. Our generation is about to see something really cool. We're not just traveling the usual 240,000 miles to the moon. We're going on a massive 1 million miles around it. Just like the Apollo 8 trip, the new Artemis 2 mission is happening at a busy time for our world. As they fly around the moon, we'll think about our own home and how brave people are to explore space. What an adventure! From the moon's mysteries to the courage of astronauts. Every step of this adventure reflects the indomitable human spirit. How much should that journey be worth? Let us know in the comments, smash that like, and subscribe for more.